This video is about the theory behind the design of my cannons. To see the cannons in action, please click up there. For the tutorial with demonstrations of actual construction, click down there. The idea of these cannons is to put as much TNT in one place at one time as possible. People have made similar stacks with pistons, but I find pistons to be unreliable, often leading to the destruction of the whole cannon. I think I invented this cannon style because I have not been able to find any other videos of them. However, it won't surprise me if somebody already published. Please let me know so that I can add a link to their work here. This ring is the basic construction unit of the cannon. Once you have one of these, you can just keep repeating and stacking them until you reach around 76 rows of dispensers. This is the limit from which TNT can fall, and it's that in the background. It's the limit the TNT can fall between the dispenser dispensing it and the actual detonation. From the 77th block, it's probably going to detonate above the water and destroy your cannon. First component is the water at the bottom. It should be exactly one block, and it should be there before you build anything else, unless you want to rebuild your cannon several times because you forgot to put the water in the bottom. Just trust me, put the water first. Second component is the dispensers. They should be stacked in rows of 4 facing inward in a ring. Third component is the firing circuit, which is red felt. The repeaters will activate 2 dispensers, so each firing ring triggers 2 rows of dispensers. Technically, you can trigger 3 rows per firing circuit, but it doesn't work as well. I'll demonstrate that later in the video. When I build a firing circuit, I always put redstone all the way around so that I can attach the timing circuit from any point. Fourth component is the timing circuit, which is blue felt. Normally it carries a signal from the signaling circuit, which is the black felt over there. But in this case, since there's only one row, we only need the carrier. We don't need the signaling circuit. So that's the basic design. I'm not going to fly this time. I'm just going to stand here. And you can stack these dispensers up to 76 rows, which is 38 firing circuits. Now, why trigger 2 rows per firing circuit instead of 3? Because it does add up to a lot of extra components. The answer is Minecraft physics. For some reason, the 2-row system works much better. I thought having fewer components would work using 3 rows per circuit, but it does not. Let me demonstrate with these 2 cannons, which each drop 24 TNT, excuse me. Alright, how high do we go? 528 was our max for that one. And that was 3 rows of dispensers per firing circuit. This one is 2 rows of dispensers per firing circuit, but it's still only 24 TNT. So, same number. And we're going to go 600, 745. So, nearly 200 higher. And that's exactly the same number of TNT. So there's a big difference in height. It's worth the extra work to build a firing circuit for every 2 rows instead of 3. Now, let's go look at the maximum size cannon and the control circuits and carrier circuits. I guess what I call a carrier circuit, you could also call a timing circuit, to be a little more accurate, I guess. Down we go. Okay. The black felt circuit controls the black control circuit brings the firing signal down from the button. Each blue carrier circuit connects and fixes the timing to synchronize the red firing circuits. I'm sure the circuit can be made with fewer components by adjusting the repeaters, but I find it's easier to synchronize all the firing circuits this way. From here down is one leg of the firing circuit, excuse me, of the signaling circuit. Now, since this is the 15th block, there has to be a repeater here to get the signal to the firing circuit. There is always another repeater at the point where the carrier and firing circuits meet. This allows the circuits to join at any point around the firing circuit without having to adjust anything else. Okay. Each carrier counts as one delay. Since every carrier has the same repeater at the end, you don't have to count it. So this next carrier is 2. When I hop past this, I'm at 2 ticks. So these carriers are set to 2 delay. And that's true all the way up to here on this leg. So I cross the repeater, I'm now at 3 ticks. So what happens when I get to 4 ticks? This leg is 4 ticks, as you can see, so here we're at 5, and that's why this hole is 15 wide. It allows the signaling circuit to be big enough, and the carrier circuits at the same time, to have 2 of these stacked. So 4 plus 1, 5. When I get to these, you can see why you have to have the 3 blocks in the carrier circuit. This, again, is the firing unit repeater that you don't count. 4 plus 1, 5. I'm falling. This cannon tops out at a 6-tick delay. 4 plus 2, 6. You could keep extending this circuit for as long as you have room on the carriers. Right now, we've reached the limit set by the TNT's fuse length. How did I establish that? Science. An experiment. I started lower and worked my way up 1 level at a time. There's a block of water at the bottom of the shaft. The water is at the same level as the water in the cannon. When I went 1 level higher, the TNT detonated above the water. So if I land on here, whoops, you can see from the debug screen that my feet are at level 79. And the water is at level 3, so that's 76 rows of repeaters is the max. I've tried using pistons to push TNT at the bottom from a wider stack into one pile, but it's never worked. The TNT always jumps above the pistons. So let's just jump in here and see where we go. Probably won't, I'm off center, so I won't go nearly as high. Yeah. I will, however, have landed in the middle of nowhere. So, that's the theory. Hope you liked it. Thanks.